Stop worrying about homework and start learning with confidence. This is Asklearn. Complete help for every subject. Like, share, subscribe for daily learning videos.
So the first thing we're looking here for is the concentration of the Cl minus and NO3 minus. And we do this by calculating the initial moles of reactants when given concentrations and volumes. And then from the balanced reaction, we can calculate the moles of BaCl2 that can react with AgNO3 using our stoichiometric ratios. And then finally, we move on to the last step of this part of the podcast, which is determining the concentrations. So we have Cl minus. So we have the moles of Cl minus left. That is 1.5 times 10 to the minus 2 divided by the volume 0.450 equals 0.0333. Then we have NO3 minus 5.0 times 10 to the minus 3 divided by 0.450, the exact same calculation as the one above, 0.0111. And then the next portion of the podcast, we will discuss how we can calculate the molarity of Ba2 plus. So from here to the solution that we have above, we add 50 mils of 0.100 molar sulfuric acid. And when we add the sulfuric acid, the Ba2 plus ions will react with the H2SO4. And we have the following reaction, that is Ba2 plus add H2SO4 in equilibrium with BaSO4 add 2H plus. And so the initial moles of H2SO4 is 5.0 times 10 to the minus 3. And so from the balanced reaction, 0.01 moles of BaCl2 generates 0.01 moles of Ba2 plus. And so therefore we can calculate the moles of Ba2 plus left. That is 5.0 times 10 to the minus 3. So now we can determine the concentration, which is the moles of Ba2 plus left divided by the total volume, that is 0.0111 molar. Lastly, we're calculating some concentrations in the final solution. So for example, NH3, 0.0333 molar. We have NH4 plus, 0.0222 molar. Then we have Ba2 plus, that is 0.111 molar, 0.0111 molar, NO3 minus, 0.0111 molar, and Cl minus, that is 0.0333 molar.